day, friends. You are welcome to your favorite learning channel, that is Royal Learning Channel. Today we are going to discuss about the chemical properties of alkanal and alkanone. We talk about the chemical properties of alkanal and alkanone. Then alkanal is known as aldehyde, while alkanone is also known as ketones. So we are going to discuss about three chemical properties of alkanal and alkanone today. So the first one is addition reaction. Then under this addition reaction, we talk about addition of hydrogen cyanide, to alkanal and alkanone. Then we have talk about addition of sodium hydrogen triosulfate 4 to alkanal and alkanone. Then number two, we talk about reduction reaction, that is reduction of alkanal and alkanone to alkanol. Reduction of alkanal and alkanone to alkanol. The alkanal will reduce to a primary alkanol, while the alkanone will reduce to a secondary alkanol. Then number three, we talk about reaction with Grignard reagents. So let's start with number one, addition reaction. So A under it is what? Reaction with hydrogen cyanide. Reaction with hydrogen cyanide. HCN. HCN is hydrogen cyanide. HCl is hydrogen cyanide. So the first one is reaction of alkanal with hydrogen cyanide. Reaction of alkanal with hydrogen cyanide. Then the reaction will take place in the presence of potassium cyanide and tetraoxosulfate 6 acid as what? As catalyst. So reaction will take place in the presence of potassium cyanide as the catalyst. So let's first look at reaction with alkanal. Number one, reaction with alkanal. Then I'm going to use the general formula to explain before I give an example under each case. So the first one, alkanal is RCHO. So RCHO reacting with what? Hydrogen cyanide. So what will be our product? Alkanal reacting with hydrogen cyanide. So the first stage, let's use structure. Double bond O, then plus hydrogen and Cn. So the double bond will break. This double bond will break. So when the double bond break, this oxygen is negative. So therefore, this place, the other side will be what? Will be positive. Then hydrogen is what? Positive. Automatically, our cyanide will be what? It will be negative. So the positive will come to what? To negative. Positive will react with negative. So this one, hydrogen will come here, while cyanide will come here. So our product will be RCH. Then the cyanide will come here, so Cn. Then O will combine with oxygen to give us OH. So it will give us what? An alkanol. So let's replace this R with an alkyl group so that we'll be able to name our products. Let's replace this R with an alkyl group. Then don't forget that this R can be any alkyl group. So let's replace this R with an alkyl group. So I want to replace R now with CH3. which is methyl, which is methyl. So CH3, I'm replacing my R now with CH3. Then C from my functional group, double bond O, then H, then plus your cyanide, hydrogen cyanide, HCN plus HCN. Then the hydrogen cyanide will be broken down into hydrogen and cyanide. Then hydrogen is positive, therefore cyanide is what is negative. Then the double bond will also break. The double bond will break. So when the double bond break, one of the bond will come here. So oxygen is negative. Then this place, the other side now, will be what? Will be positive. This place will be positive. So positive and negative. So positive will go to negative, then the negative will come to the positive side. Then our product will now be CH3, CH3, then bond with carbon, hydrogen, then your cyanide will come here. We attach to this carbon atom Cn, then hydrogen will combine with oxygen to give you OH. So can we name these products now? Let's name these products. This product is an alkanol, alkanol, but the cyanide is on the first carbon atom. Your cyanide is on the first carbon atom. So what will you call it? One cyano, one cyano. Then the name of this what structure is what is ethanol, since you're having two carbon atom. So an alkanol with two carbon atom is called what? Ethanol. So one cyano ethanol, one cyano ethanol. Normally when hydrogen cyanide reacts with alkanal, it will give us what we call cyanodrine. It will give you cyanodrine. So reaction under this addition reaction, when cyano reacts with what? When hydrogen cyanide reacts with alkanal and alkanone, it will give us what we call cyanodrine. Cyanodrine. Then you can also call this structure, or so it is, this structure is derived from alkanal. It is derived from alkanal. That is the second member of what? Of alkanal. So you can call it ethanal, ethanal, ethanal cyanodrine, ethanal cyanodrine. So you can call it ethanal cyanodrine, or you call it one cyano ethanol, one cyano ethanol. So let's move to reaction with alkanone. Reaction with alkanone. Reaction with alkanone. Now let's use the general formula of alkanone first before we use the molecular formula of a member of alkanone. Then the general formula for alkanone is RCOR. RCOR. Then if you want to write the structural formula for this RCOR, that will be, you want to react with hydrogen cyanide, hydrogen cyanide. Then let's open the structure. Let's draw the structural formula for this general formula. That will be RC double bond O, then R. That is the structural formula. So it will be very easy to use the structural formula. So for us to get our products, it will be very easy to use the what? The structural formula plus HCN, plus HCN. So the hydrogen cyanide will decompose to hydrogen and cyanide. Then hydrogen is positive, then cyanide is what? Is negative. Then the double bond will break. this double bond will break here. So one of the bond will come down. So oxygen is what? Is negative now. Is negative. So this side will be what? Will be positive. Therefore, hydrogen will go to oxygen, then the cyanide will come to this positive side. So our product will be RC. Then hydrogen and oxygen will give us what? Hydroxy hydroxy group, then R. Then the cyanide will come down to the adjacent carbon atom. That's CN. That's CN. So when hydrogen cyanide reacts with alkanal, it will give us a primary alkanol. It will give us a primary alkanol. So when it reacts with alkanol, it will give us what? A secondary alkanol. It will give us a secondary alkanol. So let's replace the two R with an alkyl group. Don't forget that the two R are alkyl groups. So let's replace with an alkyl group. Let's replace with alkyl group. So I'm going to replace the first R with CH3, then C from up. The first R with CH3, then your double bond O, then the second R with CH3. So what is the name of this alkanone? 1, 2, 3. An alkanone with 3 carbon atom is called what? Propanone. So this is propanone. This is propanone. This is propanone. Then propanone reacting with what? With hydrogen cyanide. Propanone reacting with hydrogen cyanide. So this double bond, the hydrogen cyanide will break to hydrogen positive and cyanide negative. Then the double bond will break. The double bond will break into two. So one of the double bond will come down. So oxygen is negative now. Then therefore the other side will be what? Will be positive. So hydrogen will combine with what? With negative, while the cyanide will come to this place. So our product will be CH3 carbon with, when hydrogen combine with oxygen, it will give us what? Hydroxy group, then followed by CH3, then CN. So that is our product for alkanone. That is our product for alkanone. So let's name the product form. Let's name the product form. 1, 2. So we can see that our hydroxy group is on the what? Is on the second carbon atom. Is on the second carbon atom. Then the cyanide is on the second carbon atom. We can call it 2-cyano. 2-cyano. Then 1, 2, 3. An alkanol with 3 carbon atom is called what? Propanol. Propanol. But the ol is on the second carbon atom. So we call it 2-cyanopropan. Propan. The ol is on the second carbon atom. So propan 2-ol. 2-cyanopropan 2-ol. So we can see that this is what? This is a secondary alkanol. This is a secondary alkanol. Then let's move to reaction with sodium hydrogen triisosulfate 4. Reaction with sodium hydrogen triisosulfate 4. Reaction with NaHSO3, which is called what? Sodium hydrogen triisosulfate 4. Sodium hydrogen triisosulfate 4. So number 1, Roman figure 1 under this is reaction with with alkanal. Reaction with alkanal. So let's take alkanal, the general formula for alkanal, which is R C double bond O and H. This is an alkanal, the general formula for an alkanal, then plus sodium hydrogen triisosulfate 4. I can also rewrite this sodium hydrogen triisosulfate 4 as HSO3 then Na. HSO3Na. So I can rewrite it as HSO3Na. So reacting with HSO3Na. Now let's see how we are going to form our products. Let's see how we are going to form our products. So the sodium hydrogen triisosulfate we decompose to hydrogen and sodium triisosulfate. So hydrogen is positive, then sodium hydrogen triisosulfate is what? Is negative. Then the double bond will break. This double bond will break, then one of the bond will come down here. So at this side now, oxygen is negative, while this side is what? Is positive. Then the positive will react with what? With negative. The positive will react with negative, while the negative will what? Will react with positive. So then our product will be RC, then hydrogen or plus, then this bond, this one remaining one bond. So oxygen will combine with what? With hydrogen to give us OH. Then this oxygen combine with hydrogen to give us OH. Then the sodium hydrogen triisosulfate will come down. So that is our product. That is our product. So let's take a non-alkyl group. Let's take a non-alkyl group so that we'll be able to name the product form. Let's take an alkyl group. I'm going to use methyl, which is CH3. Now I'm replacing my R with CH3, which is an alkyl group, then followed by C, hydrogen, then my double bond. Then I want to react with sodium hydrogen triisosulfate plus HSO3Na. So the sodium hydrogen triisosulfate will decompose to hydrogen positive and sodium triisosulfate what? Negative. Then the double bond will break. So one of the bond will come here. So one of the double bond will come here. Then oxygen is negative now. Then the other side will be what? Will be positive. So therefore, positive will combine with negative. Then the positive will combine with oxygen negative to give us. So let's see our product form now. CH3, CH3, then C into hydrogen, then followed by the hydrogen combined with oxygen to give us OH, then SO3Na. SO3Na. So let's name the product form. Now, when we look at this structure, SO3Na is a substituent. SO3Na is a substituent. So this is our root hydrocarbon. Then OH shows that this hydrocarbon belongs to what? It belongs to an alkanol. This is an alkanol. So an alkanol with two carbon atom, 1, 2, is called what? Ethanol. So let's name now. It will now be sodium. We name this positive ion for sodium. Ethanol. Sodium ethanol, because our root hydrocarbon is ethanol. Sodium ethanol sulfonate. Or you call it sodium ethanol triisosulfate 4. sulfate 4. So that is the name of the product form, sodium ethanol sulfonate or sodium ethanol triazosulfate 4. Sodium ethanol triazosulfate 4. So that is our reaction when sodium hydrogen triazosulfate 4 reacts with what? With alkanal. Reaction with alkanal. So let's move to reaction with alkanone. Reaction with alkanone. With alkanone. I'm still going to start with the general formula for alkanone, which is RCOR. RCOR. Then reacts with what? Reacting with sodium hydrogen triazosulfate 4. Reacting with sodium hydrogen triazosulfate 4, which I can also write as HSO3Na. HSO3Na. Then the sodium hydrogen triazosulfate 4 will decompose to hydrogen positive and sodium triazosulfate 4 negative. Then the double bond here will break. This double bond will break. So one of the bond will come down. So when this double bond break, one of the two bond will come down. So when one of those two bond comes down, then oxygen will be negative, then this side will be what? Will be positive. So hydrogen will combine with what? With negative, while sodium sulfonate will combine with what? With positive. Then our product will be RC. Then oxygen combine with hydrogen to give us what? Hydroxy group. Then followed by what? Your R. Then with your sodium sulfonate, that's SO3Na. So that is the product form. But we cannot name what? We cannot name our products because the two are unknown. They are unknown alkyl group. So let's replace the two R with an alkyl group. So we'll be able to name our product form. Let's replace the two R here with an alkyl group. So we are still going to start from the reactant side. So our R now, I want to replace with CH3, which is methyl. Then followed by C double bond O. Then the second R I want to replace with CH3, which is an alkyl group. So this is our what? Our reactant side. Then reacting with what? Sodium hydrogen triazosulfate 4. So let's react with sodium hydrogen triazosulfate 4. Then this one will be broken down to positive sodium hydrogen and sodium sulfonate negative. Then the double bond here will break. So one of the chemical bond will come down. So oxygen will be negative, then this side will be what? Positive. So hydrogen will combine with what? With negative. Hydrogen will combine with negative to give us CH3, then C. Then the double bond here has broken into two. So we have one bond now. Then hydrogen combine with a negative to give us OH. Then the sodium sulfonate will come to this positive side. This is negative. The sodium sulfonate will come to the positive side to give us what? To give us SO3Na. Then CH3 we attach plus CH3. So this is our product form. This is the product form. So we can name our products now. So what can we call this product? what can we call these products? So when we look at the straight chain hydrocarbon, the root hydrocarbon is an alkanol. The root hydrocarbon is an alkanol, which is the third member of alkanol. You can call it the third member of alkanol. You can name it according to an alkanol, then you can name it as an alkane at the same time. So I'm going to name it in two ways. So if it is an alkanol, the ol will be on the second carbon atom. So you name your sodium first. That will be sodium. Sodium, the ol is on the second carbon atom. Propan 2 ol, propan 2, propan 2 ol, then triazosulfate 4. Triazosulfate, triazosulfate 4. Then you can also call it, or you can call it sodium. Then if I want to name it as an alkane, 1 2, the hydroxyl group is on the second carbon atom. I'll call it sodium 2 hydroxyl. Then the third member of alkane is what? Propane. Propane sulfonate. Propane sulfonate, or you call it triazosulfate what? 6. Triazosulfate 6. So that is the name of the what? Of the product form. Let's move to reduction reaction. So reduction to alkanol. Don't forget that I said that the an alkanol will reduce to what? A primary alkanol, while alkanone will reduce to what? A secondary alkanol. So let's move to reduction reaction. Then number two chemical reaction. Number two is reduction to alkanol. Reduction to alkanol. The reaction will take place in the presence of lithium aluminium tetrahalide, or NaBrH4. So it's either you use lithium aluminium tetrahalide as your catalyst, or you use sodium bromine tetrahalide as your catalyst. Then let's take the first example with alkanal. Then we can call this reaction catalytic hydrogenation. We can call it catalytic hydrogenation because hydrogen will be added. Hydrogen will be added as a reducing agent from from either of these two what? Of the two catalysts. So with alkanal, reaction with alkanal, let's use molecular formula first to explain. Plus, then hydrogen now from what? From your reducing agents. From hydrogen from your reducing agents. I'm putting this hydrogen in brackets because it is not what? Hydrogen gas. It is not a hydrogen gas. So it is coming from what? From your reducing agent, which is lithium aluminium tetrahalide. Lithium aluminium tetrahalide. So I'm taking this hydrogen now from reducing agent. Then what is reduction? Reduction is what? Addition of hydrogen. Reduction is addition of hydrogen. So that's why we are adding this hydrogen from our what? Our reducing agents. So let's see the product form. Let's see the product form. I'm going to decompose this hydrogen into two. Then the double bond will break. The double bond will break. So oxygen will be negative. Then automatically this side will be what? Will be positive. So the bond, one of the bond has opened and attached to this side. So this place is positive now, this place is what? Negative. Then the two hydrogen that we have, so one will come here. One of the hydrogen will go here, then the other hydrogen will come here. So our products will now be R C, then the hydrogen that we have up, then this hydrogen will come here. Hydrogen, then followed by what? Hydrogen will combine with oxygen to give us what? OH, which is an hydroxy group, an hydroxyl group. So this is the structural formula for alkanol. An alkanol is what is formed. Then if you look at this alkanol, only one alkyl group attached to the carbon atom that is holding the functional group. One alkyl group is bonded to the carbon atom holding the functional group. And when one alkyl group is bonded with a carbon atom holding your functional group under alkanol, you call this what? A primary alkanol. So when alkanal reacts with what? With a reducing agent, a primary alkanol is formed. A primary alkanol is formed. So let's take an example of what? Of a primary alkanol. Let's take an example of a primary alkanol. I want to replace this R with C2H5. C2H5 followed by C, then hydrogen, this is an alkanal now. I'm replacing with what? I replace R with C2H5, then O, plus our what? Our reducing agent. Hydrogen from what? From your reducing agent. Then your what? Your reducing agent on the arrow. Then this hydrogen will split into two. Then the double bond from oxygen will break down into two. So one of the double bond will come here. So oxygen is what? Is negative now. So one of the hydrogen will come here. We attach with oxygen, and the other hydrogen we attach with this what? With this empty bond here. So our product will now be C2H5, C2H5, then followed by C with one hydrogen up. Then this hydrogen will enter here, attached to the adjacent carbon atom. So hydrogen, then followed by, then the hydrogen will combine with this oxygen to give us what? OH. OH. So this is a what? This is a primary alkanol, because only one alkyl group, which is C2H5. C2H5 is ethyl. So only one alkyl group attached to the carbon atom holding your functional group. One alkyl group bonded to the carbon atom holding your functional group. So therefore, this structure belongs to us, a primary alkanol. So let's name the product form. An alkanol with 3 carbon atoms is called what? Propanol. 2 here plus 1, that's 3 carbon atoms. That will be the third member of alkanol, which is called propanol. So the name of the product is what? Propanol. Propanol. So let's move to reaction with alkanone. Reaction with alkanone. Reaction with alkanone. So the general formula for alkanone is RCOR. So the structural formula will be R, C double bond O, then R. Reacting with what? our reducing agents, hydrogen from our reducing agents. So you bring in hydrogen from your reducing agents. So your reducing agent is lithium, aluminum, tetrahalide. So bring in hydrogen from the reducing agents. So the hydrogen, the two hydrogen will split into HH. Then your double bond will break down into two. So when it is broken into two, so one of this double bond, one of the chemical bond will come here, one of the bond will come down. So our product will now be R C. So one of this double bond has come down here, so it will remain only one bond here. Then oxygen. So oxygen is negative now. Then the bond down, followed by the what? The alkyl group. So one of the hydrogen will combine with oxygen to give us what? Hydroxyaion. This hydrogen will combine, then the second hydrogen will attach to this adjacent carbon atom. So if you look at it now, if you look at this structure, we have two alkyl group. We have two alkyl group bonded to the carbon atom holding our functional group. And when two alkyl group are bonded to the carbon atom holding your functional group, you call this what? A secondary alkanol. A secondary alkanol. So therefore, a secondary alkanol is formed. So take note, when alkanal react with a reducing agent, so it reduces it to what? A primary alkanol, while alkanone reduces to what? A secondary alkanol. So let's take an example of a known alkanone. So let's take an example of a known alkanone. So we replace this R with an alkyl group, CH3, C double bond O. Then I'm going to use another alkyl group. Let me use C2H5. Then plus hydrogen from our what? Our reducing agent. Then in the presence of lithium, aluminum tetrahalide. So the hydrogen will split into two. So double bond, the double bond will break. Then this one will be negative. Then one of the double bond will come down. So therefore, we are going to have CH3, C. Then the double bond has broken. So this one will remain only one bond. Then the second bond will come down. The second bond will come down. Then followed by what? C2H5. C2H5. So the oxygen here we combine with what? With hydrogen to give us hydroxy group. Then the second hydrogen will come to this adjacent carbon atom. So we can see that now we have two alkyl group bonded to the carbon atom holding the functional group. So the structure belongs to what? A secondary alkanol. So this is a secondary alkanol. So let's name the product form. Let's name the product form. 1, 2, 3. So we have 4 carbon atoms. The straight chain hydrocarbon 1, 2 plus 2, that is 4. So that is the fourth member of alkanol, which is butanol. But the all is on the second carbon atom, so we call it butan 2 all. So that is the name of the product form, butan 2 all. Then let's move to the third reaction. The third reaction with what? With Grignard reagent. Reaction with Grignard reagent. Reaction with Grignard reagent. Number 3. Reaction with Grignard reagent. So which is RMGX. RMGX. So your R is your alkyl group. M is magnesium, while X can be any member of what? Of halogen. So you replace your X with any member of halogen. So RMgX is a Grignard reagent whereby R is an alkyl group, Mg is magnesium, while X is what? Any member of what? Of halogen, a member of halogen. So let's take the first reaction with alkanal. Reaction with alkanal. Then this chemical reaction is of two stages. In the first stage, an alkanal or alkanone will react with your Grignard reagents, So the second stage, your product form will now be hydrolyzed. So the hydrolysis will be the second what? The second stage. Now, I'm going to use the general formula for alkanal first, which is RCHO, to explain the first stage. So R, C double bond O, then H, plus our Grignard reagent. So I want to replace this Grignard reagent, the R, with CH3. Don't forget that your R is an alkyl group, then Mg, then you replace X with any member of halogen. You replace X with any member of halogen. Let me use bromine. So what will you call this one? Methyl magnesium bromide. You call it methyl magnesium bromide. So it is reacting with what? Methyl magnesium bromide. So what will be our product now? What will be our product? So the double bond will break. The double bond will break. So one of these double bond will come down. So this one will be positive, then oxygen will be negative. Then this methyl magnesium bromide will be broken down to CH3, which is an alkyl group. So an alkyl group is negative. Then while magnesium bromide is what? Is positive. Is positive. So positive we combine with negative, and negative we combine with positive. So the negative with positive, so this one will come here, CH3 will come here. So our product will now be RC, then hydrogen up, followed by CH3 down, then we are left with one oxygen here. So the double bond has broken down into two, then MgBr will join, MgBr. MgBr. Now, the second stage, our product form here will be hydrolyzed. So hydrolysis. Then what is the meaning of hydrolysis? Hydrolysis means what? Addition of water. So you add water molecule. So your water molecule can now be broken down to OH and what? An hydroxy ion. So it will give you OH and H. So our product here we split into O and MgBr. So this O is positive, then MgBr is what? Is negative. So therefore, O is negative, oxygen is negative, then MgBr is what? Is positive. So hydroxy ion we combine with what? With positive, because hydroxy ion is what? Is negative, while hydrogen, which is positive, will combine with what? With oxygen. So our product will now be RC, then hydrogen up, then CH3 down, then oxygen here we combine with what? With hydrogen to give us OH, then plus MgBr we combine with OH to give us Mg, OH, then Br. this is what? A basic salt. So it will give us an alkanol and what? And a basic salt. So let's take a known alkanal, so that we'll be able to what? Name the product form. Due to this R, we cannot name this product because this R can be what? Any alkyl group. So let's take an example of a known alkanal. Let's take an example of a known alkanal. So I'm going to replace this R with an alkyl group, then followed by double bond O, then your hydrogen. So this is what? A known alkanal. So this, what's the name of this alkanal? That is ethanal. Ethanal. Ethanal reacting with what? Your Grignard reagent. So I'll use CH3, then Mg, then Br. Since this X can be what? Any halogen, Br. So let's look at the product form. How are we going to form our product? So your Grignard reagent will break down into an alkyl group, which is what? Which is negative, and this one which is what? With positive. Then the double bond will break into what? Into two. So one bond will come down here. So our product will now be CH3. See, so one of the double bond has opened. So the oxygen is what? Is negative now. Oxygen is negative. So why this side will be what? Will be positive. This side will be positive. So let me do it in this way. Let me draw the structure in this way. CH3, C double bond O, then hydrogen. Let our structure be in this form. So the double bond will be broken down into two. Oxygen is negative, then this side will be what? This side will be positive. So positive will combine with what? With negative, while negative will combine with positive. So at this side now we have CH3 followed by carbon with one hydrogen up. Then this CH3 will combine with what? This negative side. So CH3 will enter here. Then oxygen will combine with what? With positive, which is OMgBr. So that is the first stage, the product form for the first stage. Now, this first stage will be hydrolyzed. So our product form will be hydrolyzed. So hydrolysis now. So we add what? Water molecule, which is OH, OH minus, and H plus, H plus. So our product here will now, this product will break. So oxygen is negative, oxygen side is negative, then this side is what? Is positive. So hydrogen will combine with negative, then the hydroxy group will combine with positive. So our products will now be, so what we have now, CH3, C, hydrogen, then O, oxygen will combine with what? With positive, that's to give us OH, then CH3 down, the adjacent carbon atom, then plus our positive here will combine with hydroxy group to give us Mg, OH, then Br. So that is our product form. That is the product form. So what's the name of this alkanol? What's the name of this alkanol? So let's number the continuous carbon chain. The continuous carbon chain. 1, 2, 3. 1, 2, 3. So this is what? Propanol. This is propanol, but the ol is on the second carbon atom. So we call this propanol. propan 2-or. So propan 2-or is formed with what? With a basic salt. With a basic salt. So the next one is reaction with alkanone. Reaction with alkanone. Reaction with alkanone. B with alkanone. Then the general formula for alkanone is RCOR. RCOR. So let's use structural formula. Let's use structural formula. R C double bond O, then R plus our Grignard reagents. Our Grignard reagents, which is RMgX. Then we give us what? It will give us what? The R will split. This product will split. That is, your Grignard reagent will split. Then R is what? Is negative, while MgX is what? Is positive. Then oxygen will also break. The double bond will break. So when the double bond breaks, so oxygen is what? Is negative. Oxygen is negative. So therefore, MgX will combine with what? With O. Then YR will combine with what? This side. Then our product, this is positive now because the double bond has broken down into two. So we have R, C, then one oxygen. Then that oxygen now will combine with negative here to give us Mg what? MgX. Then followed by this R. The R will come here to give us R, then another R here. Another R here. So then the second stage, our products will now be what? It will be hydrolyzed. So the water molecule will what? We split into hydrogen and what? An hydroxy ion. Then the MgO and MgX will break. So our product will now be RC, R. Then oxygen will combine with what? With positive ion, because oxygen is negative, to give us what? OH. Then plus MgX will combine with hydroxy group. MgX will combine with hydroxy group to give us MgOH what? X. So let's replace with a known alkanone. I'm going to replace with a known alkanone now and see our product form. Now, I want to replace the first R with CH3. I want to replace my first R with methyl, then double bond O, then the second R with CH3. Then let's use a non-Grignard reagent now. Let's use a non-Grignard reagent. So R is an alkyl group. I can use methyl, then Mg. Then I'm not going to use bromine this time around. Let me use chlorine. So because S can be what? Any halogen. It can be any halogen. So what will be our product for the first stage? The Grignard reagent will split into CH3. CH3 is negative. MgCl is what? Is positive. Then the double bond will also break. This double bond will break. Then oxygen will be negative. So one of the bond will now come down. So our products will now be CH3, C. So this one will remain one bond. Oxygen. Then positive. So MgCl will come here. So MgCl. Then followed by your CH3. CH3 at this side. Then the methyl group, that is the alkyl group, will come here because this is positive. So your CH3 will come here. So the products now, our products here will be hydrolyzed. It will be hydrolyzed. So it will be hydrolyzed. Then the water molecule will split into hydroxy ion and hydrogen ion. So this one too will what? Will break. So oxygen is negative while this place is positive. So hydrogen will combine with what? With negative to give us, our product will now be CH3C. Then the hydrogen combine with oxygen to give us OH. Then followed by CH3. Then CH3 plus, so MgCl will combine with what? With hydroxy ion to give us MgOH, then Cl. So this is the product form. These are product form. Then let's name the product form. Let's name the product form. We first what? We number the longest continuous carbon chain. Let's number the longest continuous carbon chain. 1, 2, 3. 1, 2, 3. So we have hydroxy group. Then we have what? Methyl on the second carbon atom. So 2 hydroxy, 2 hydroxy. Then the methyl is on the second carbon atom. 2 methyl. So an alkane with 3 carbon atom is called what? Propane. So the name of this product is 2-hydroxy 2-methyl propane. 2-hydroxy 2-methyl propane. So we have come to the end of today's class. I'm going to explain other chemical reaction of alkane and alkanal in my next video. I'm going to explain condensation reaction. I will explain oxidation reaction of alkanal and alkanone in my next video. Remember to subscribe to Royal Learning Channel. Share this video with your friends and comment. Bye.